Alrighty, hello. I'm going to take a few minutes here and walk through this Chapter 7 review because I know that I'm going to be gone a few days, and also, if we decide not to have school on Wednesday or something, you guys have all of the answers and my explanations for them. So here we go. Number one, Tammy plans to put a wallpaper border around the perimeter of her room. She will not put the border across the doorway, which is 3 feet wide. Okay, so here's Tammy's room. She's putting a border around the edges. Okay, so I saw a lot of people trying to find the area today. We don't want to find the area here. We want to find the perimeter. But remember, there's a doorway here, and that doorway is 3 feet wide. Okay, so if we want to write a polynomial that represents the number of feet of wallpaper, we need to find the perimeter. Okay, so we need a 2x minus 1. We need an x plus 4. We need another 2x minus 1. But then from that, that's where the doorway is. So we have to subtract 3 out of that. Okay? And then you need another x plus 4. All right? So now we just combine like terms. So we've got 1, 2, 3, 4, 5, 6 x's. So 6x. And then negative 1 plus 4 is 3. 3 minus 1 is 2. 2 minus 3 is negative 1, and negative 1 plus 4 is a positive 3, okay? And since we are in feet, that would be the correct unit to use there. So we've got 6x plus 3 feet, all right? A local store has 50 feet of border that Tammy has chosen. What is the greatest whole number value of x in which the amount would be enough? Okay, so if we know that the perimeter is 6x plus 3, and we want that to be 50 or as close to 50 as possible, let's just see what it is if it equals 50. So if we subtract 3, you're left with 6x is equal to 43. Okay, and then we go to our handy dandy, or sorry, not 43, 47. Sorry. 47. And then we go to our handy dandy calculator here and we do 47 divided by 6, which is 7.83. Okay, so we're not quite to 8, which means that 8 would be too much, right? If we plugged in 8 here, 6 times 8 plus 3, that would give you 51. That's too much, right? They only have 50. So that means that the greatest whole number is 7. So x has to be the value, or 7 has to be the value of x here, okay? On C, determine the dimensions of Tammy's room for the value of x that you found. Okay, so now all we need to do is we need to take 7 and plug them back in up here. All right, so if we've got 2x minus 1, that's like 2 times 7 minus 1, which is 14 minus 1, which is 13. Oh, sorry, you can't see. Apologize. Okay, so we've got 13 feet by, all right, well, the other one is x plus 4, which is 7 plus 4, which is 11 feet. Okay, so the dimensions are 13 by 11. Those are the dimensions. Okay. Number 2, the length of each side of a cube is 14x plus 8 feet. Write a polynomial in standard form, that's important, in standard form, to represent the surface area of the cube. Okay, well, let's start by drawing a cube. So I've got a square and a square. Okay, and we've got a cube here. Not perfect, but it's fine. And the length of each side is 14x plus 8. So 14x plus 8. And then this side is 14x plus 8. Okay. So the surface area is just the area of all of the surfaces. Well, if you notice that a cube is made up of squares, and it's made up of 6 squares. So what we have is we've got 6 times whatever the area is of the square. Well, the square's area is 14x plus 8 times 14x plus 8. And so now we can simplify because that's not standard form. Make sure you follow the directions and write it in standard form. Okay? So you've got 6 times, well, handy dandy calculator here. 14 times 14 is 196 x squared. 14x times 8, that's 112, but you've got another one. So 112 and 112 is 224x, and then 8 and 8 is a positive 64. Okay? So that's the area of one side of the cube, but there are 6 sides. So now we distribute. 196 times 6 gives you 1,176x squared. 224 times 6 equals 1,344x. And 64 times 6 is 384. Okay? So that would be a polynomial to represent the surface area of that cube. Okay? It's kind of gross and really, the numbers are big, but that's okay. Write a polynomial in standard form to represent the volume of the cube. Okay, well the volume is the base times the height times the width. So we've got the 3 dimensions now. So we've got the base times the height times the width. So now we've got just one more 14x plus 8. Well, we know that this right here, we found that. That's this. So I'm just going to copy and paste that. So that's 196x squared plus 224x plus 64. And we need to multiply that by 14x plus 8. Okay, so here we go. 196 times 14 is 2,744x cubed. And then 196x squared, so 196 times 8 is 1568, but then we also need to add 224 times 14. So when we do that, you get 4,704x squared. And then 224 times 8 is 1792, but then you also add 64 times 14, and you get 2,688x, and then 64 times 8 is 512. Okay? So that's kind of the situation that we got going on here for that one. And then that's all that you can do. You just got to stop there. Okay? All right. Beautiful. All right. You are framing a picture with a frame of equal width on each side. So what this means is the picture here is 20 by 16. And the frame is X inches wide on every side. Okay? So, write a polynomial that represents the perimeter, including the frame. Okay, so we know that if we start here and walk to there, that's X plus, and then that length is 20, and then that length is X. And then we got to turn around. Okay, well then the length from here, let's see, from here to here, wait, hold on. So we're there. So we've got 20 plus 1, 2x is that side, okay? And now the length here, okay, we know that we've got 16 on this side, but we also have this side there and that side there. So it's like you've got 16, but you also have an x on each side. And then you've got the same thing on that side. So you've got 20 plus the x's on each side. Okay. And then the last one is a 16 and an x on each side. So now you just got to combine like terms. So 1, 2, 3, 4, 5, 6, 7, 8 x's. And then 20 plus 20 is 40. 40 plus 32 is 72. So that's the perimeter. Okay. So if we write a polynomial that represents the area, okay, well, if the length is 20 plus 2x, right, because you've got 2 x's on each, or an x on each side, and then you've got 16 plus 2x, 20 times 16 is equal to 320. 20 times 2 is 40x. 2x times 16 is 32x. 2x times 2x is a 4x squared. Now you just combine like terms. So you've got 320 plus 72x plus 4x squared. And then in standard form, so on your test you're going to have to write things in standard form, you would just start with the 4x squared plus 72x plus 320. So that's where we would be. Okay. And then finally for C, find the perimeter and area of the picture including the frame when the width is 2 inches. Okay, so that means that the X value is 2 inches. And if we want to find the perimeter, well, we found the perimeter up there. So all we do is plug in that X value there. And then you get 16 plus 72. And 16 plus 72 is equal to 88 inches. Okay, it's perimeter, so it's just one dimension. And then for the area, well, we found for that polynomial up there, so if we plug in the 2 for that, and if you plug that into your calculator, you're going to get 192 inches. But this time, because it's area, we have to square it. So we have 192 square inches. Okay. All right, moving on. Number 4. You are building a brick patio. The length of the patio is x plus 11 feet. The total area of the patio can be represented by x squared plus 14x plus 33. Write an expression for the width of the patio. Okay, so we know that the length is x plus 11, and we know that length times width is equal to the area, and we're given the area, so we need to find that missing dimension. Well, if you think about it through factoring, if we want to get to that 33 and we've got an 11, then that means that that has to be a 3 there, and we have to have a plus sign. So x plus 3 feet would be the width of that patio. Okay, and so now if we're going to find the perimeter of the patio, well, we've got two sides that are of length x plus 11 and two sides that are of length x plus 3. So if we distribute, you get 2x plus 22 plus 2x plus 6. And then you combine like terms, so you get 4x plus 28. Okay, so that's the perimeter of the patio. Now for the bottom, assume that the value of x is 3. You're putting edging around the patio and have a budget of $200. You found that edging costs $2.75 per foot. Is the edging within your budget? Okay, so the edging is going to go around the patio, so we're talking about the perimeter, which is helpful because we already found the perimeter. But now we want to assume that x is 3. Okay, so we plug in 3. So we've got 4 times 3 plus 28, which is 40. So that means that we've got 40 feet worth of things happening here, but each foot costs $2.75. So then from there, we know that we can spend $110, and that is within our budget. Woohoo! We can do that. That works. Sorry, you couldn't see. Okay? Alrighty. That's awesome. Okay? Great. Let's go ahead and do a couple more here, and then I'll put the rest in part 2. So here we go. We've got this area of a circle, okay? So we want to write an expression for this shaded area here, okay? So if you notice, you have a big circle and you have a little circle. And my game plan here is to find the area of the big circle and find the area of the little circle and subtract it out, because it's kind of like you've got this little circle that's being hole punched out of it, okay? So the area of a circle is pi r squared. So the area of the big circle is going to be pi times the radius. Well, the radius is this entire thing, and that entire thing there is going to be 2x plus 2 squared. And if we write that out, that's like 2x plus 2 times 2x plus 2, which if you FOIL, turns out to be 4x squared plus 4x plus 4x plus 4, which turns out to be 4x squared plus 8x plus 4. And then you distribute that pi. So you're left with 4 pi x squared plus 8 pi x plus 4 pi. So that's the area of that big circle. Now we got to think about the area of this smaller circle, okay? And the area is going to be pi times the radius, but this time the radius is just x squared. So if we simplify that, then we've really just got pi x squared. So we need to subtract pi x squared from that area up there. And the good thing is we have a like term. 4 pi x squared minus 1 pi x squared. Well, that just gives you 3 pi x squared. And then the rest of that, those aren't like terms. So those just stay on the back just like that, and you leave your answer in terms of pi. Okay? Not too crazy here, right? All right, let's do the other one, like the circle in here. Okay, so here we've got another circle, but now it's not in the middle. Okay, and we're given the diameter of that circle instead. But the good thing here is that the diameter of that circle is the same thing as the radius of the big circle. Okay, so same situation here. The area of the big circle is going to be pi times the radius, which is x squared, which just turns out to be pi x squared. Okay? Well, the area then of the little circle is pi times, okay, so the radius of this circle is going to be half of that diameter. So it's like 1/2 x squared. Well, okay, so hopefully you remember from exponent rules that when you have a squared like that, that squared power applies to both. Okay, so if we take 1 divided by 2 and square it, we're going to get 1/4. Okay, so be careful with that arithmetic there. You've got pi times 1/4, and then that 2 comes to that x as well. So if we put this in the correct order, you would have 1/4 pi x squared. So if we want to find now the area of that shaded region, you're going to take the area of the full circle and subtract out the area of that little square. And as luck would have it, those are like terms. You've got 1 pi x squared minus 1/4 pi x squared, and 1 minus 1/4 is 3/4 pi x squared. And that's where you would stop there. Okay? All right, I'm going to pause there so that this video doesn't get obnoxiously long. The 7 through 15 will be on video part 2. Okay?